Hello everyone, I'm Kota Murakami. This is a podcast that reviews technology and business information focusing on the blockchain industry in both Japanese and English. Today's guest is Daniel Wang, founder and CEO of Taiko Labs, building a Type 1 Ethereum equivalent ZK-EVM on the Ethereum. Daniel, thank you for coming today.
It's nice to be here, Kota. Thank you for having me.
Thank you very much. So at the beginning, please introduce yourself about your background.
Sure. So I'm from a technical background. I was an engineer by training. Got my master's degree in computer science in the US, and then started working for Google as a software engineer. And then I left Google to join startups. I also co-founded a few startups in China, in Beijing and Shanghai. I think in 2013, I had my own startup to build an exchange for Bitcoin. Mm-hmm. And then a few years later, in 2017, I founded Loopring, which is also a ZK rollup scalability solution for Ethereum. So I can say I'm a very pro Ethereum developer. I see myself as a developer. I still write code on a daily basis. I try to stop that, but sometimes it's just hard to resist writing code. So yeah, general background is engineering. I still sort of trying to switch to like a leading management role as of now. Yeah, that's pretty much what I am.
Thank you very much. So you also mentioned, but like you also developed the layer 2 technology, like which is very famous, Loopring. You are also fond of Loopring, but why did you decide to start the Taiko?
Sure, that's a pretty good question. So when I and the team developed Loopring, it was actually the very first ZK rollup in production for Ethereum. But it has some limitations. First of all, Loopring is very centralized. We run a relayer to sequence transactions, and we also run provers to prove our own blocks. Right. So basically, it's a centralized solution. The other limitation is that Loopring is application specific, meaning that that rollup can only do certain things like NFT minting, swapping, and ERC20 transfers, trading, etc. It's not programmable, so it's not general purpose. So given the nature of centralized and application specific, it doesn't allow like a composability, things like that. Those nice features are missing from Loopring. But I also have to say that Loopring is very, very cost efficient in terms of settling the transactions on layer 1. So that's the benefit that other layer 2s don't have.
Mm-hmm. Okay, thank you very much. So for the third question, Taiko is targeting Type 1 ZK-EVM. For those who are familiar with ZK-EVM, but not with the different types, please explain the difference between Type 1 ZK-EVM like Taiko and other types, please.
Sure. So being Type 1 means we stick with the Ethereum specification as much as possible. We have to use the same hashing algorithm, the same like signature algorithm, etc. Especially we have to use the same Patricia-Merkle tree structure for the storage. All these specifications are followed by Taiko to make sure, first of all, the user experience is exactly the same as on Ethereum, with only very few exceptions. For example, the protocol dump sharding, the blob transactions doesn't make sense on layer 2. So that's not part of the Taiko specification. So being Type 1 strictly, you have to follow everything exactly the same, right? But Taiko, the goal is not to be exactly the Type 1. The goal of Taiko is to make sure, for 99% of the developers who right now are working on their like Ethereum prototypes, right? They can just migrate to Taiko without any change of their code. But if you have a ZK rollup yourself, right? And then if you migrate to Taiko, then you still need to change something. So being type 1 really means the best user experience or the same user developer experience for the majority of all the existing and future developers. So we call it Ethereum equivalent ZK rollup. Yeah. So the reason, the benefit of being type 1 is really obvious to a lot of people. So besides what I just said about the developer experience, it also means if there is some bug in our circuit, we can easily identify those bugs because we can reuse the Ethereum client software, which have been like thoroughly tested, very stable, right? And since we are using the same set of code, then it's really unlikely that we introduce bugs in Taiko client. So it's easier for us to identify issues with our circuits. The circuit codes are also pretty complicated. So you have a new client, and then in the same time, you also have a new set of circuits. It's really hard to debug. There are obvious other reasons. We can talk about that later. But in general, that's what I mean by like type 1 ZK-EVM, highly equivalent to Ethereum.
So also you mentioned about the Inception layers reusing the same type 1 code base, which can unlock extremely extensible scalability for Ethereum. And you mentioned this one in Ethereum Tokyo last month. Can you please explain in detail what that is and also how it can be achieved?
Sure. So I watched the movie Inception, where you can have one dream inside another dream, right? So this Inception layer, through this concept, we really want to highlight the fact that the Taiko technical solution is not just a layer 2 solution, it's a multi-layer scalability solution on Ethereum. So since Taiko is type 1 ZK-EVM, we can deploy the Taiko protocol on top of Taiko itself. So if we deploy Taiko on Ethereum, then Taiko is Taiko layer 2. If we deploy Taiko on top of Taiko layer 2, then we have Taiko layer 3s, right? The magic part of this design is that you have one set of code, and it works for all the layers. And a natural question to ask is, why do we need layer 3s? Why do we need multiple layer 2s, right? So that's if we don't have the challenge, we don't need a solution. So when people talk about scalability, most people talk about two things. One is the throughput, like how many computation or settlement can you done through Ethereum, or the blockchain. And the second issue is like the cost of transactions, right? Whether the gas is low enough to support billions of users. But there's a third challenge in scalability, which is the state explosion issue, I call it. So basically, if a lot of users, 1 billion users, come to one layer 2 or layer 3, their state, the world state will be too large so that only a few high-end hardware can run full nodes. This is very problematic for layer 1s because, as being too centralized, the security will be sacrificed, right? So for layer 2s, this is less a problem, but in terms of security, but it's still a problem for like availability. Like if you have like 3 or 4 nodes running the network, full nodes, you can imagine someday maybe they are down and the network is gone, right? So we still feel like, any layer 2 on any layer 3 by itself cannot support a lot of people. So we need multiple layer 2s or layer 3s to effectively partition user into smaller like world states. They can transfer their asset across layer 2s or layer 3s, but on any single layer 2 or layer 3, the state is manageable. It's not going to be too large. So that's why we feel like in the long run, there will not only be multiple layer 2s, but very many layer 3s, maybe like 1,000, even more layer 3s.
Right.
And Taiko being the one-stop solution for multi-layer scalability, once it's well tested, then when we launch the mainnet, it's not just a layer 2 Taiko, it's a set of layers, right? One or multiple layer 2s with multiple layer 3s. So people can some applications like a gaming related applications can have their own layer 3s. They can just change the configuration a little bit and boom, they have layer 3s for themselves, right? So that's the cool part. The other aspect of this cool part is that since we have one solution for layer 2 and layer 3s, all the proving is the same. So if we have hardware partners, they can run their cluster to prove all Taiko layer 2s and layer 3s.
Oh, okay.
Yeah. So I imagine even for other type of ZK-EVM, eventually they will have their own layer 3s as well.
Right.
For them, they may have to change their protocol a lot because their protocol is designed and implemented for Ethereum, not for their own chain. So that's I think the one benefit of being like type 1 ZK-EVM.
So you mentioned this one, this Inception layers. So this Inception layers can do it only for type 1 ZK-EVM, not for the type 2 or type 3 ZK-EVM cannot doing this one, right?
Well, they can, but they need to modify their design to adopt their layer 2's features, right? Because Taiko's protocol is designed for Ethereum, and Taiko itself is equivalent to Ethereum. So that's why we can deploy without any change. But if you imagine like your layer 2 has a different signing algorithm, has a different even like a programming language, then the protocol you designed for Ethereum, it doesn't fit into
Right.
layer 2. So that's the problem. Yeah.
Okay. Thank you very much for the explanation. So thank you for Daniel coming to our podcast.
No, thank you for having me again, Kota.
Thank you.